Good day, everyone, and welcome to the Engineer Construction Lecture Hub. I want to talk about a very important topic, okay, that has to do with construction of our slabs. All right, today's topic is orientation, orientation of reinforcements, orientation of reinforcements in slabs, in slab. Okay, that's the topic for today. Now, you discover that in slabs, reinforcements are arranged in a matted format. Okay, we have the bottom distribution, we have the bottom bars, okay, running across the short span. We have the distribution running along the longer span. Now, I've talked about one-way spanning slab. I've talked about two-way spanning slab. Now, I want you to know that slabs are hinged to beams. Okay, for them to perform optimally, they should be properly anchored. There should be proper anchorage, of these slabs to the beam. But our concentration today is for us to see how these reinforcements are being positioned, on as in the matted format of slabs. Okay, now I want you to understand that there are most times for example, we have our panel in this form. Then we have another panel, okay, that runs this way. We have another panel that runs this way. Okay, so you can see, for instance, we have two panels. Okay, the panel I mean is the partition within the slab, because the slab we don't treat it as a one unit. Okay, we treat per meter run. So, and also we consider the various partitions within that building plan. The individual partitions, we treat them separately. We provide reinforcement separately. Okay, then together they can now form a unit, as in the entire slab of that building. Okay, so for example, we have two partitions. We have partition 1, partition 2. Okay, now the orientation of our reinforcement, we know that the main bar runs at the bottom. The main bars run at bottom. Then distribution bars runs at top. Okay, so I want you to note that. All right, now you see that from our design, we must have designed for this panel. We have designed for this panel. Now it's for us to now interpret, or a kind of translate what the output of our design into a detailed drawing. Now, for example, we have here as 2 meters. Okay, we have here as 2 meters, this way 2 meters. Okay, then we have this path as 4 meters. Then we have here as 6 meters. Okay, all right, so now you discover that when we want to run reinforcement for these two panels, okay, you discover that you can decide to run a bar across this way, okay. Now you can decide to also run this way. You can also run this one this way, okay. Now I want you to note that if you look at this bar now, this bar that crosses these two panels, you discover that at this point now, this one now is acting as the main bar, okay. Let's say here is 2 meters. Let's say here is 2 meters, okay. Then here 2 meters. Now you see that this bar that runs, you can decide to have this to act as the main bar for this panel. That is, you can have this reinforcement that crosses these two panels on this panel A. This is panel A. This is panel A. This is panel B. So for panel A, this can act as a bottom, okay. While in panel B, the same reinforcement can act as a top. The reason is that this part is short, okay, the same as this part, okay. So you can decide to run this as your bottom on this panel A. Then this the same reinforcement will now be turned to a top reinforcement when it crosses this beam. When it crosses this beam in between, once it crosses, this reinforcement will no longer be bottom on this panel, though it's bottom on this panel. But once it crosses this beam, it will no longer be bottom on this panel. Rather, this reinforcement will now act as the bottom because it crosses the short span. So this reinforcement now will now be the top, of this bottom reinforcement. So I want you to take note of that. A lot of persons normally do this mistake on site, where you see them, since it's one reinforcement, they run everything at once as bottom. It is wrong. It is wrong. You have to look at the span of that slab, okay. That panel, you have to consider the panel, the slab, the span of that panel, okay. It is very, very important. So understand that when you're using a one reinforcement across two panels, you must understand their conditions, okay. The side that have shorter span, that the same reinforcement should run at the bottom. Then when the other span is longer along that span, that reinforcement will now translate or will now be transferred to be top at that other panel. So take note of that. It is very, very important because a lot of our slabs do perform poorly. Yeah, they do perform poorly because some of these lapses were not, considered, were not looked into, critically. We just let reinforcement works to the iron fitters to do. Okay, as a site engineer, you're expected to look at this reinforcement arrangement, these orientations, before you can certify it okay for concrete operation, so that at the end of the day we can have a functional and a slab that can perform optimally. Okay, so I deem it necessary to bring this for our notice. All right, so I'm going to stop here for today. Please like this video, share, comment, and most importantly, follow this page for more updates. Thank you very much and have a wonderful day. Thank you.